Good morning, college. Today we are going to solve exercise 336 from the book Fundamentals of Electrical Circuits Sadiku. In this exercise he tells me to repeat problem 3.6 applying loop analysis. Here is problem 3.6 tells me to apply nodal analysis to obtain V0 in the circuit in the figure. We applied nodal analysis this time to obtain V sub 0, which was the voltage between this point and this point, but this time we have to do it through loop analysis. I recommend you see exercise 3.6 to corroborate this well. First let's demarcate the ties. Here I have sub 1. Some call it mesh 1 and 2 and we do the LVCA analysis. Let's remember that when we work with loops or meshes, whatever you want to call it, we are doing an analysis of Kirchhoff's voltage law, where we analyze the voltages in a loop and then in mesh 1 I have the voltage between this point and this point. Well, they are 12 volts and I am going to put less here. Well, between this point and this point we are going to do it between this point. This point would be how the current comes, so it would be minus 12 volts between this and this point and this point. The voltage would be then mesh current 1 times the resistance would be plus 4 times in 1. And between this point and this point, it would be the current that passes through the resistance 6 times the current of the resistance, that is, current times voltage resistance. We need the voltage here. It would be 6 because of the current that passes through here, but since it is within 2 loops, we have to do N1 minus N2 because there is 1 minus N2 and no N2 minus N1 for the direction. For the analysis what we are doing. In mesh 1 as it is mesh 1, we assume that current 1 is greater than current 2. Well, now applying algebra it would be 12 plus 4 and 1 plus 6 and 1 and minus 6 and 2. This is equal to 0. If I apply algebra, and 1 would be, this would be 10 and 1. And 2 minus 6 and 2 equals 2. Some take the output polarities, that is, here it comes out for more would be more. And here as the current goes like this is polarized more or less, they take this part as less. That depends on each person, just as the result has to be the same. So the first equation would be 10 and 1 minus 6 and 2 equals 12. I'm going to delete this. And now we're going to do the analysis in loop 2. I'm going to delete this. I'm going to do the analysis here in loop 2 and 2. Then I'm going to make it red. You know, in the tension here. Here it is current through resistance. The resistance is 6 and the current, well, since we are now in loop 2, I had deleted it. Here 1 and 1 we use lasso 2 because we say that it is and 2 is greater than in 1 because we are analyzing both. Then the voltage between here and here. Well, we have a voltage source. It would be plus 10 and the voltage between here and here varies. The resistance or here would be plus 2 and the current that multiplies that resistance would be I2. Let's ignore this current in 3 and 2 and 1. Let's ignore it for the moment, because I'm doing loop analysis, so it's going to be equal to 0. We apply it algebra 6 and 2 minus 6 and 1 plus 2 and 2 equals minus 10. So whatever has minus 6 and 1 if in law 2 would be plus 8 and 2 equals minus 10. So the equation would be -6 and 1 plus 8 and 2 equals -10. Let's put that in the I'm going to use MATLAB here. It would be 10 space -6 semicolon hey -6 space 8. How much? The result would be 12 semicolon. We go to the other row -10. We check if it's okay. 10 minus 6 and 12. 10 minus 6 and 12 minus 6. 8 and 10 minus 6. 8 and minus 10. I put -10, -10. Okay. Let's look. And it tells me that the currents are 0.81 amperes and -6.63 amperes. I come here and say that the current in one, it's 0.81 amps. The current in 2 is -0.63 amperes. That is the loop current. Now it tells me to determine that V sub 0 and V sub 0 is over the resistance 6 ohms. Let's observe that the current that polarizes that resistance when we did loop analysis. Node analysis. What a pity. In exercise 3.6 the current into the current 2 goes downwards. Therefore it would polarize more or less, and it makes sense because this is ground. So the voltage V sub 0, which is the voltage between this point and this point, is equal to the resistance, which would be 6, which multiplies the current and 1 minus the N2, that why 1 minus N2 because the current N1, when we find it, has the polarity, the same direction as the current N2 or the same direction as the polarity of this resistance. Although if the polarity had suddenly been more here and less here, then we would have taken Y2. Now this is going to be the same, huh? We can use it with a calculator, right? I'm going to do it with MATLAB. I'm going to say that it would be 6 which multiplies G in position 1 minus G in position 2. Son, huh? The variable I called is a diminutive of solvario. In order to do that, I'm going to put it here. Look here, I said that as a solution I put the sun. So if I put the sun in the position, you could call it whatever you want. Or if you want, give me the value of 10.8182 and Sol in position 2 gives the second, which is minus 0.634. So what I'm going to do is I'm going to say that 6 multiplies, and in parentheses I'm going to put solvario in position 1 minus solvario in position 2. If assuming, like here, 6 that multiplies this because Malaya has these variables saved, I'm going to hitting enter tells me it is 8.7273 volts. .72 volts. 8.72 volts. Please verify it with the video of exercise 3.6 and you will corroborate it. See you at the next one.